Download this code from codegive.com, link in the description below. Certainly. Load balancing is a critical aspect of distributed systems and can significantly affect the performance and reliability of applications. When we talk about manifold in the context of load balancing, it often refers to the manifold, or surface, that represents the load distribution across different servers or resources. In this tutorial, we will explore advanced load balancing techniques, including how to implement them using code examples. Overview of load balancing. Load balancing involves distributing workloads across multiple computing resources, such as servers, network links, or CPUs, to ensure optimal resource use, maximize throughput, minimize response time, and avoid overload of any single resource. Advanced load balancing techniques. 1. Round robin. This is the simplest form of load balancing. Requests are distributed sequentially across the available servers. 2. Least connections. This algorithm directs traffic to the server with the least number of active connections. 3. IP hashing. This method uses the client's IP address to determine which server will handle the request, providing a consistent server experience for clients. 4. Weighted load balancing. In this method, servers are assigned weights based on their capacity, requests are distributed according to these weights. 5. Health checks. Regular health checks ensure that requests are only sent to healthy servers. 6. Sticky sessions. This technique allows a session to stick to a particular server, useful in cases where session data is stored locally on the server. 7. Manifold load balancing. This involves creating a manifold, or model, that predicts load distribution and adjusts in real time based on various metrics. Implementation example. For this example, we will build a simple load balancer in Python using Flask to implement a weighted round-robin load balancing strategy with health checks. Step 1. Set up the Flask servers. First, we'll create two simple Flask servers that will simulate our backend. Save these as server1.py and server2.py. Python. server1.py. From Flask import Flask. Import random. Import time. App equals Flask, underscore underscore name underscore underscore. At approot, / def home. Time.sleep, random.uniform, 0.1, 0.5, simulate variable latency. Return response from server 1. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. App run, port equals 5001. Python. server2.py. From Flask import Flask. Import random. Import time. App equals Flask, underscore underscore name underscore underscore. At approot, / def home. Time.sleep, random.uniform, 0.1, 0.5, simulate variable latency. Return response from server 2. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. App run, port equals 5002. Step 2, create the load balancer. Now, let's create the load balancer using Flask. This will implement a weighted round-robin strategy and perform health checks. Python. Load underscore balancer.py. From Flask import Flask, redirect. Import requests. Import time. App equals Flask, underscore underscore name underscore underscore. Server configuration. Servers equals. URL, http://localhost 5001, weight, 3, active, true, server 1 has a weight of 3. URL, http://localhost 5002, weight, 1, active, true, server 2 has a weight of 1. Keep track of the current server index. Current_index equals 0. Def get _next server. Global current_index. Total weight equals sum, server weight for server in servers if server active. If total weight equals 0. Return none, all servers are down. Get the next server based on weights. While true. Server equals server's current_index. If server active. Move to the next server. Current_index equals, current_index plus 1, %len, servers. Return server URL. Current_index equals, current_index plus 1, %len, servers. Def health_check. For server in servers. Try. Response equals requests.get, server URL, timeout equals 1. Server active equals response.status_code equals 200. Accept requests.exceptions.request exception. Server active equals false. At uproot, / def load_balancer. Health_check, run health checks periodically. Server URL equals get_next server. If server URL. Response equals requests.get, server URL. Return response.text. Else. Return all servers are down, 503. If __name __equals __main__. App run, port equals 5000. Step 3, running the servers. 1. Start the first server. Bash. Python server 1.py. 2. Start the second server. Bash. Python server 2.py. 3. Start the load balancer. Bash. Python load_balancer.py. Step 4, testing the load balancer. You can test the load balancer by sending requests to http://localhost 5000. You should see responses alternating between server 1 and server 2, according to their weights. Conclusion. In this tutorial, we explored advanced load balancing techniques with a specific focus on a weighted round-robin strategy, health checks, and how to implement them using Flask in Python. This example can be extended further to include more sophisticated algorithms, metrics, and logging for production use. Further considerations. Consider adding logging for monitoring and debugging. Implement a more robust failure detection mechanism. Explore using libraries like Nginx or HAProxy for production-grade load balancing. Scale horizontally with container orchestration tools like Kubernetes for managing microservices effectively. Feel free to ask if you have further questions or need additional information.